Describe the end behavior for f of x equals 3x to the fifth plus 4x to the fourth minus 5x cubed plus 2x squared minus 10x minus 5. Now it's a pretty long polynomial, right? There's like 6 terms in here, right? But remember, the end behavior refers to what is happening to y as x gets really large, right? So we can write it more technically this way, right? As x approaches infinity, what is f of x doing? Okay. And when we say what is f of x doing, we mean is f of x going larger to positive infinity or smaller to negative infinity? Okay. And along the same lines, what is happening as x approaches negative infinity? Right? Same thing. As x is getting smaller and smaller, what is f of x doing? Okay. So remember, end behavior refers to the ends of the graph. Okay. So this is not the answer here, right? But basically, as x gets really large, right? So as x goes to infinity, right? As x is getting really large, is your graph going up or is your graph going down, right? Remember, these are the f of x values. So what is f of x doing? Is f of x getting larger or is f of x getting smaller? And similarly, as x approaches negative infinity, right? As your x values are getting smaller and smaller, is your graph going up and to the left or down and to the right? Okay. So how do we determine that? And that's determined by the end behavior. Okay. So, I'm sorry. That is the end behavior. It is determined by the leading term. Sorry about that. Right? It's determined by the leading term. Now, I'm not saying that the remaining terms are not important. Okay. But because it's x to the fifth power, right, it sort of dominates every other term here. Okay. So first thing we can note is that the leading term. Okay. First thing we should do is the leading term here. And it's positive, right? It's not negative 3, it's positive. The fact that it's 3 doesn't really matter, but we just want to look at two things. The leading term is positive and the degree is odd, right? So we know that this is a 5th degree polynomial whose leading term is positive. Okay, so what can we conclude about that? We can conclude that as x approaches infinity, right? Think about this. No matter what happens, as x gets really large, the y values are going to get larger as well, right? This graph should go up and to the right. Okay. But what about as x gets really small, right? As we're going down this direction, like imagine, plug in negative 10 into the whole function. And then plug in negative 100 and plug in negative 1,000 and see what the graph is doing. And the good thing about polynomials is they follow a certain pattern. All polynomials follow a certain pattern. So we can conclude because this polynomial is odd and because the leading term is positive, we're going to go down and to the left. So as x is getting smaller and smaller, right, every y value should also be getting smaller and smaller. Okay. So we say up and to the right, which means that f of x is approaching positive infinity, and down and to the left, which means that f of x is approaching negative infinity. Okay? So that's the more technical way to write it, right? So as we're going to the right, which means as x is getting bigger, f of x is also getting bigger. And as x is getting smaller, or as we're going to the left, right, the y values are getting smaller, which means f of x is approaching negative infinity.